transformed like this, and prayers were written and then illuminated with medieval designs. Right? So the Greek underneath is being now transposed and made visual with X-rays. And if you go, you know TED Talk?
Yeah.
Oh, go TED Talk, Archimedes, Professor Mike
No.
Professor Noel, and he goes to a beautiful extent to show you how each letter of the Archimedes comes back with the shooting of the X-rays, and it's really fascinating. It's really a fascinating lecture, and shows how they're working on the third book Archimedes. First book Archimedes, second book Archimedes. So again, the King of Sicily, Federico II, which is an amazing guy to know. He purchased the one book at the time known of Archimedes that was in the library of Constantinople, and gave as a gift to the Pope. The Pope was trying to excommunicate him all the time because this guy was fascinating, multicultural, and he spoke Arabic, he spoke Greek, he spoke Latin, and he by nature was so all-inclusive, and that the Pope wanted him to go for a crusade to conquer Constantinople, to conquer Jerusalem, and he didn't want to go, so he would start writing with the Sultan, and they would negotiate solutions. They would say, yeah, you want the Sparta, okay, you come in, I give you the Sparta, without wearing blood. When eventually he actually went there without killing anybody, the Pope was like, wait, you didn't kill any Muslim in this one, something's wrong, then maybe you are Muslim. Because he was actually corresponding all the time with these, with the libraries of the time, which were the sultans and the emir of the time, had some of the most important libraries of Greek literature, because after, basically they were paying as much gold, as much a book would weigh, if you would translate a Greek text or a story, for example, in Arabic. So if you have the book in Arabic and you give to the Sultan, he will give you as much gold as the book. So can you imagine their libraries? They were extremely rich. That's why lots of that literature survived, because it was in these Muslim, in the hands of these Muslim libraries. And that goes around through Spain with Federico II. Federico II, we have letters where he's asking, what did Aristotle mean when he was saying this or that? And librarians from the Sultan responding. They would say, maybe this is the reason. There is beautiful letters in the correspondence. Going back to letters, our important letters are Archimedes, Eratosthenes. Archimedes here, Eratosthenes in Egypt, in Alexander of Egypt, and they're writing to each other. So we have tons of this letter. We have lots of things to Archimedes. Nobody reads it, nobody knows about them. It's extremely fascinating. So the concepts go this way. If you have let's start and see if I can make it a little quicker. Let's say that this is a string. The piano is closed. Whose glasses are these? Can I?
Sure.
So try to think this is a string of a piano, a string of a violin, a string of a guitar, a string of a lute, anything, a string, right? This string, you play it, it has a sound. Do has a sound. This sound, if I cut the string in half, and I pluck this string in half, I obtain the same sound, but one octave higher. Do, do, right? Then if I divide this in 3/4, so I pluck in here, I obtain another sound, which is do, re, mi, fa, sol, so the fifth. The fifth above the do, which matches the fourth below, but is the fifth above. So we are 2/3, so as this is half, right? Then we go to 2/3. Then we go to 3/4. And the numbers are 1, the string, 1, 2, half the octave, 2/3, the fifth, 2, 3. 3/4 is the fourth. All perfect intervals. When Pythagoras is the one that puts this in writing in his school, was one of his discoveries. It could have occurred before, so all the names I'm telling you now, they're not people that just came out of nothing. They are the result of their teachers, their professors, because Pythagoras, before being in Crotone, he actually was in Babylonia. So all this knowledge, it comes from all this traveling. These people were traveling more than we do today. So these numbers, remember, 1, 2, 3, 4. Important numbers, simple numbers, fractions, whole numbers. They were fascinating. When Pythagoras found this, he found that not only this worked on the string, but if you are hammering and trying to do a sword, for example, right? And you have a hammer. If the hammer has this volume, makes a certain sound. But if the hammer has half the volume, makes a sound which is the octave higher. If it has 2/3, it makes the 5th sound. But so at one point, Pythagoras was mesmerized, was like these numbers match specific volumes, weights, geometry, and solids at the same time, nature. So the thing will continue, but the concept was like nature has in common, which means the square, the circle, the sound, musiche. Pythagoras, they called it musiche, musica. Musica, music, musiche. Music is what all the further to do with the music's inspiration. Today with music we intend the arts, theater, everything else. At the time, with Pythagoras, musiche was music because music, sounds had these mathematical relations, had these numbers, and these numbers were a secret code of nature. The number became the connection between the sounds, the world that you don't see, you hear the sound, you don't see the sound, connects with that number. The same number has one. There was the perite, for example, that was shaped in pentagons, right? The solids, and then you find that in Calabria. You find these, in the fields outside. So there were things in nature that match these numbers. I'm not going to tell you each origin of all these things, but for example, a cube. The cube was the temple, the altar for the Greek temple for Apollo, for the oracle, but was also the one with the eternal light in Babylonia. So the cube has a volume, and then the pyramid, 4 sides. The pyramid has, think of the pyramid not like the Egyptian pyramid. The perfect solid pyramid is triangle, 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 triangle. The base is a triangle. A tetrahedron, 4 sides. 1, 2, 3, 4. That's a pyramid. The pyramids are not pyramids, the one that we know. You know that, right? I don't need to say anything about it, or you know what the pyramids are. In fact, they are octahedrons. The Egyptians, better me, they wanted only perfection. You could reach the afterlife, the pharaoh could reach the afterlife and maintain life only if was in a perfect solid. That pyramid is not a perfect solid, has 4 sides plus the base, 5. The other pyramid, in fact, is underground. When you look at the pyramid in Egypt, you have to think 4 plus 4 degree underground becomes the octahedron. It's 8,000. Then there's a dodecahedron, and the isohedron. So these are since Plato, we know these are the only regular solids that we have. Each solid had shapes. The shapes were the square, and then triangle, and so forth. Numbers. Going back to Pythagoras, if you have a triangle, we have no triangles here. Anyway, triangles, there is a 90 degrees like this, right? 90 degrees, and then the hypotenusa, which is below. The 90 degrees are here. It's like, let's say this ceiling. So the hypotenusa is called hypotenusa because it stays below, and the 90 degrees stay there. Once you have 90, that all the other angles put together, they have to bring 180. So that's the idea. Now, if you have 2 plus 3, total is 5. In the Sicilian mind of the time, 2 plus 3 was not 5. Right? Was 13. How is this possible? So I'm trying to say these things because the way of thinking, of seeing the world was different. Again, the numbers were not the numbers. The 1 was a 2 for them. And the mathematic numbers were geometry. So if you have, what was the great discovery of Pythagoras that we know today? If you have this triangle, right, you build a square on one side of the triangle, you build a square on the other side of the triangle, and these two squares put together are the same surface of the square built in the hypotenusa. So one square plus that square built equals the square built below. Is this clear to your mind? You remember this from school? Kind of? Okay.
Yeah.
They were thinking always in this shape. So when they looked at a floor, what they looked was geometry. That's why you have to be a geometra to be in the school with Pythagoras. It was geometry. It was not mathematics as we know now. Though the word mathematics was originated with Pythagoras. All the people they wanted to learn from Pythagoras, the learning from it was called the mathema. And from mathema, from the school of Pythagoras, come mathematico, mathematicians come from that. Right? So it comes, mathematics comes from this geometry, seeing the world in volumes. Goes where? Into the Renaissance. How do you recognize the Renaissance palace? Because you see the square, you see the 3/4, you see the 2/3, you see the 5th, you see the 4th. You go to Palladio. What is Palladio? Frozen music. Frozen music, why? Do you hear sounds? No, because each room of the Palladio has the specific number, the 1 to 2, the 2 to 3, the 3 to 4, the basic numbers of Pythagoras. But Pythagoras found also something else, was a secret that made him suffer, eventually died out. One of his students was actually killed in this. When you have this triangle, if you take a unit to measure, because you know there are no meters at the time, so the unit is all relative. If you take a unit and you measure one side, and then you measure the other side, and then with the same unit, you measure the hypotenusa, it doesn't work. The hypotenusa has a number that is an infinite number, is a crazy number, an irrational number. It's no longer 1, 2, 3, 4 numbers, all numbers or fractions of numbers. It becomes an irrational number. Pythagoras had built all his school, all his philosophy based on the whole numbers, on these professional numbers in nature. The infinite number would kill all his systems. So this was a secret. It's a legend, but they say that one of his students actually was eventually killed because he was sharing the secret of the infinite. But because of the infinite, eventually people died in 1600 because they were being burned in Rome in the church because they were saying there is infinite worlds, there is infinite, the concept of infinite was a problem. So Pythagoras eventually finds the infinite because that was the measurement of the hypotenusa, the relationship with the sides, but doesn't get up because he doesn't like that concept. And we go to Archimedes. Archimedes instead works on the concept of infinite. So Archimedes is doing what? We have a square, we have a circle. How do you relate a circle with a square? How do you transform? If you are measuring land and you have a square field, and then you have a round field, how do you say, I pay this much for the square, I pay this much for the circle? You have to measure it, right? How do you measure a circle, right? So, from the Bible, we already have, we talk about the Old Bible, the Jewish Bible, we already have a number. The Bible gives us a number 3, that is a code, a secret code, a number, a secret relation for the circle, the number 3. So Archimedes already had some knowledge, right, what could be the relationship between the circle, right, and the circumference of the circle and the radius or the diameter. He had this tree around. So Archimedes comes up with what we call the most amazing piece of music, which Michael helped me to remember is?
I can't right now.
2 pi r. You know what a pi is, right? Okay, 2 pi r squared, right? 4 pi r squared, 4/3 pi r cubed. Does it make sense? These numbers, do they make sense to you? The circumference, the surface of a circle, the surface of a sphere, the volume of a sphere. Now, this is high mathematics. This is not something that you say today, oh, I know exactly what we're talking about, right? How did he find out? I cannot tell you right now, but you cannot, it's fascinating what he does. He cuts the sphere in half, puts a cone inside, it slices and I mean, what Archimedes was doing was incredible. And writes a Eratosthenes on the other side, who on his own was making enormous amount of discoveries, because what we find out from there, they knew in Aswan in Egypt, in the equator, they had a well like the equator where it was very clear that on a day of the year, 2 days of the year, the sun would go straight down, no shade. On the same day in Alexander of Egypt, or in Syracuse here, the sun will create a shadow. So here in Sicily, there was a shadow like this. In Aswan on the same day, no shadow. So because they could measure distances with camels, they knew how many steps a camel could do in a day, and counting the days that it would take from Aswan to go to Alexander of Egypt, they knew the distance, right? So according to the distance, they knew that shade, they had the shade would give you an angle, right? With the angle you had the angle. You had the side of the shade, because it was the distance measured with the camel. With the simple Euclid triangle, you could find exactly the missing information, missing numbers. And so with the simple triangle, these people were able to measure, and they start the first parallel, the parallel radians basically started there with it. So we're talking about 240 years